All right, we're going to start with the 1 to warm up. So the first said to evaluate the function at each indicated value. What are we doing with these values that are inside the parentheses? Just plugging them in. Good. So I'm going to take that -2. I'm going to plug it in everywhere there's an x. So I'd get 2, -2 squared plus a -2 minus 1. So be careful with your order of operations here. People tend to screw up the signs on this stuff. You are squaring a -2 first, which means that becomes a +4. This would be -2 minus 1. So that's 8 minus 2 minus 1, or 6 minus 1, which is 5. So be really careful. Remember, when you're plugging in the values, you're keeping it inside the parentheses. Then I go to where f is, question? Okay. Where f is, or where x is -a, so I'm going to plug in 2 -a squared plus a -a minus 1 and simplify it. So the -a squared becomes a +a squared times 2 minus a minus 1. Can't simplify it any further, so it stays just like that. Still good? Okay, 3, I'm taking x plus 1 and plugging it in. So this is 2 times x plus 1 squared plus x plus 1 minus 1. Then I'm going to expand and FOIL the x plus 1 times x plus 1. So 2x plus 1 times x plus 1 plus x plus 1. I can get rid of the parentheses without having to change any sign because it's a positive in front. This becomes 2. This is x squared plus 2x plus 1, once you FOIL and combine your like term, plus x, +1 and -1 cancel out. God bless you. And then I'm going to distribute the 2 to each of the terms here. 2x squared plus 4x plus 2 plus x. Combine your like terms. 2x squared plus 5x plus 2. So be careful with your signs. Be careful with your steps there. People make silly mistakes when there's more steps involved, okay? Okay, then we got to domain. So a review on domain. Remember that it is all real numbers except for 3 cases. What's one? Variable in the denominator. What's another one?
Variable in the square root.
Variable under square root. The third is the combination of the 2, right? Variable in the denominator underneath the square root. So if you look at 4, what I have to test for is my denominator here. So I would say that this cannot equal 0. 3x cannot equal -1, and x cannot equal -1/3. So you can either write it like that, or you can say all real numbers except -1/3. So this or this. You don't need both. Questions on that one? Okay, 5. I've got both cases going on. I've got a square root in the top. This has to be greater than or equal to 0. And I've got a square root in the bottom. It has to be greater than 0. So my numerator gives me the restriction that x has to be greater than or equal to -1. My denominator gives me the restriction that x has to be greater than 3. So if I look at these two on a number line, greater than or equal to -1 is a solid dot on -1, everything to the right. The denominator says greater than 3. Open dot on 3, everything to the right. Which one am I picking? The x has to be greater than 3. It is more restricted. You want the more restricted one because otherwise the other stuff won't work for the bottom. So again, 2 ways to write it. X is greater than 3, or all real numbers. Greater than, not greater than or equal to, but greater than 3. Questions? Questions on the homework from last night? Okay, remember you can go back in after 8 a.m. and you can see the correct answers.
The last one.
Okay. All right, so this one said find the difference quotient given f of x equals 9x to the third plus 7x. Okay, remember difference quotient is f of x plus h minus f of x all over h. So the first thing I'm going to do is find f of x plus h using this f of x. So my x plus h is going in to both of the x's. I get 9 times x plus h to the third plus 7 times x plus h. I get 9x plus h times x plus h times x plus h. plus, I can distribute this out now, 7x plus 7h. So we did this yesterday. We did x plus h times x plus h. So I know that it is x squared plus 2xh plus h squared. But if you don't remember that, just FOIL it back out again. And then I've got to distribute it one more time. So the x squared is going to both the x and the h. So I get 9 on the front. This is x to the third plus x squared h. Then the 2xh is going to both. So plus 2x squared h plus 2xh squared. And then the h squared is going to both, plus h squared x plus h to the third. Plus 7x plus 7h. When you look at what's inside the parentheses, you want to see if there's any like terms. The 9 is still on the front. There's only an x to the third. There are 2x squared h's, 1 and 2, which becomes 3x squared h. And there are 2xh squareds. One has a 2 and one has a 1. So that's also 3xh squared. And the order of the letters there doesn't matter. Plus 7x plus 7h. Then you've got to distribute the 9. 9x to the third plus 27x squared h plus 27xh squared plus 9h to the third plus 7x plus h. 7h, sorry. That whole thing is f of x plus h, okay? Be really careful with your signs. Every single term, you got to be careful with your sign. Now from here, I got to subtract my f of x, which is 9x to the third plus 7x. So I get 9x to the third plus 27x squared h plus 27xh squared plus 9h to the third plus 7x plus 7h minus 9x to the third minus 7x. Then comes the canceling. Positive 9x to the third, negative 9x to the third. Positive 7x, negative 7x. And from that, I have 27x squared h plus 27xh squared plus 9h to the third plus 7h. And the last step is what? It all goes over? H. And then the h's. So I have 27x squared plus 27xh plus 9h squared plus 7. Be very careful with so many steps. It's really easy to make a silly mistake. Yeah, the 9 and the 7 changed. The process is exactly the same. You still had to cube something. You still had to distribute it. But the 9, I think it was the 9 and the 7. Yeah, the 9 and the 7 changed. So your numbers could have been different, but the process is exactly the same.
Oh, where's the 7x and the 7h on the side?
That is from the very beginning. My initial thing was 9x to the third plus 7x. So wherever the x went, which was the x here and the x here, was my x plus h. So that 7 got distributed to the x and the h. You might have had different numbers, but it was the same process. All right, so now we're going to get into graphs of functions. So yesterday we talked about what is the function, how to identify it from points, how to identify it from an equation, how to evaluate it, find domain, and then the difference quotient. Now we're going to get into the graphs of the functions. So we start with domain and range from a graph. So we talked about domain yesterday, but now we're going to talk about it from a graph. When you're reading domain and range from a graph, okay, you're going to put this in interval notation, so we're going to review that in a minute. Domain is your values from left to right. So as you look at your graph, what values are on your graphs or your lines from left to right? Those are your x values. That's domain. Range is from bottom to top. Your y values, you start at the bottom, you go to the top. These are going to be written in interval notation. So if you came from regular, you maybe didn't see interval notation. If you came from honors, you did. Okay? But interval notation is, instead of saying it in terms of like x is greater than 3, you write it so that what numbers are there would be 3, and then everything bigger than 3, which means I'm going to go to positive infinity. If it's a greater than or a less than without the or equal to, we put a parentheses on the number. The parentheses is kind of like an open dot on a number line. And infinity always gets a parentheses because infinity is not a single number. You can't include it. If it said something like x is less than 3, now we're going from the smallest numbers possible, which is negative infinity, up to 3. Again, both gets parentheses because infinity always gets a parentheses, and 3 is not an or equal, so it gets a parentheses, not a bracket. If it is or equal to, so x is greater than or equal to 3, now I'm starting at 3 and going to positive infinity, but I am including 3, so it gets a bracket. And if it's less than or equal to, I'm starting at negative infinity, I'm going to 3, but I'm including 3, so it gets a bracket. If there is a start and a stop, so if the arrows are there, like pointing right or pointing left, that's when you're going to get infinity, okay? If there is a start or a stop, like x is in between negative 2 and positive 3, then both of the numbers are your endpoints on your interval notation. Negative 2 would come first because that's the smaller. 3 would come second. And then you determine if it's a parentheses or a bracket based on the inequality sign. So if it doesn't have the or equal to, it gets a parentheses. If it has an or equal to, it gets a bracket. So if we are including the point on our graph, it gets a bracket. If you are not including it, if it's an open dot, it gets a parentheses. So open dot, parentheses, solid dot, bracket, infinity, always parentheses, in negative infinity or infinity. Because you can't define infinity. I can't tell you to include infinity because it's not an actual number. Okay, you'll also get asked to find an indicated value on a graph. So if it says find the indicated value and it says find f of 3, okay? Then you're going to look on your graph where your x, because that's what's inside the parentheses, is 3, and you're going to give the y coordinate that matches that point. So the answer to that would be whatever the y value is on that point. Again, I'll show you this on a graph, but. Okay, example 1 says find the domain and range and the indicated function value. So the first thing I'm going to do is just look at my graph. Okay, if you need to mark your points, mark your points. This is -1, this is -2, this is -3, this is -4, okay? -1, +1, obviously that's 0. So my domain goes in which direction? Left to right. So if I look from left to right, which is my x's, what's the furthest left point that's included on my graph, on this curve here? -4. Does everybody see that? Is it an open dot or a solid dot? Solid dot, so it gets a bracket. What's the furthest point to the right on that graph? -1. Is it an open dot or a solid dot? Solid, so again, it gets the bracket. There's my domain. So my domain is all the numbers between -4 and -1, including -4 and -1. Next, I'll do range, and range goes bottom to top, so we're talking y values. What's the lowest y value that's on this graph? -2. Is it an open dot or solid dot? Solid, so it gets a bracket. What's the highest point on this graph? 2. It doesn't have to be an actual dot, right? That is a solid part of my graph up here. That means there is dots there. That means that is a point there. So the highest one is 2, and it's a solid line, so it's a solid dot, which means it gets a bracket. So domain, left to right, range, bottom to top. X values, Y values. Okay, second part says, find the indicated function value. So A says, tell me the Y value when X is -4. So I'm going to go to my graph. I'm going to find where X is -4, which is here. And I'm going to say, this is the point on the graph in which my X is -4. What's the Y that corresponds to it? What is that point? -4, what? -2. So the Y there is -2. B says find where F is -1. So I'm going to go to my graph. I'm going to find where F is -1, where X is -1, which is here. What's the coordinate there? -1 and 1. So my Y is 1. So the inside the parentheses is your X. It's giving you your X. You are getting from it the Y value. Questions on that one? All right, we're going to use our graphing calculator. So again, if you don't have your handheld, you can use the app, but you eventually want to get comfortable enough on your handheld so that you can answer questions, because on your test, you're going to have a portion that has to be on your handheld. Okay, so I have my graphing calculator in front of me. I want to enter a graph. It says use the graphing utility to graph the function. So I'm going to hit the Y equals. And I get something like this, okay? The newer ones have the color. The older ones have all black and white. It's fine, same thing, okay? In that box, Y is the same as f of x. So if it says f of x equals the absolute value of x plus 2, I'm going straight to absolute value of x plus 2. Now, if you look like on your function keys, there's no absolute value like bar. It's under math. So if you go to math and you go over to number, the very first thing says ABS. That's absolute value. You're going to hit enter on that. Then what I want in there is x plus 2. You don't want to use the letter x. You want to use the variable button, which is next to the alpha button. And it says x, t, theta, n. That's the button you want to use. X, and then plus 2. Hit enter. Everybody with me so far? Then I'm going to go to graph. And it's going to graph my function. So this says use a graphing utility to graph the function, estimate its domain and range, and then verify the result algebraically. So what I need, if this is my homework, is a screenshot of what's on my calculator right now. Okay, you could take a picture with your actual iPad, or you could use the graphing calculator app and you could take a screenshot. But you need that because now we're going to answer questions on this. So if I move left to right on this function, what can you tell me about the x values? What happens? What does it mean by getting cut off on the edges?
It means it keeps
It's going to keep going, right? So what's the smallest x value that's going to be on this graph? Negative infinity. Okay, it's just the same as having an arrow. An arrow pointing left means negative infinity. What's the largest x value? Positive infinity. With me so far? Now the range is bottom to top. What's the lowest y that's on this graph? 0. Is it a solid dot or is it an open dot? Solid dot, so it gets a bracket. What's the highest y? What's going to keep happening to these? They're going to keep getting bigger and bigger. It's going to positive infinity. And that always gets a parentheses. Still good? Yep. All right, then it says verify the result algebraically. What you're going to verify algebraically is the domain. So go back to the rules we learned about yesterday. Okay, algebraically means go back to your domain rules. So if you go back to the domain rules from yesterday, look at your domain. Is there a variable in the square root? Is there a variable under a denominator? Is there a variable under the square root in the denominator? Which means, what's the domain? All real numbers. Negative infinity to positive infinity. Make sense? Yes? If there was a square root in this, then whatever I get from my graph should match the restriction I have on my square root. Does that make sense? Okay, good. All right, vertical line test. So remember yesterday I told you there's 3 ways that you're going to look for a function. The first was looking at the points. The x can't repeat with a different y. The second was looking at an equation. The y can't be raised to an even power or an absolute value. The third is this, the vertical line test. So if you can draw a vertical line through your graph and it intersects your graph at more than one point, it fails your vertical line test. It is not a function. So example 2 says use the vertical line test to determine whether the curve is the graph of a function of x, and if it is, state the domain and range of the function. So let's look at A. If I draw vertical lines through A, moving from left to right, anywhere on this graph, do any of those intersect my graph at more than one point? No, which tells me this is a function. Now the second part of my instruction said if it is a function, find domain and range. So if this is 1, 2, 3, 4, what's the furthest point left? What's my domain? 0, 2, 4. Brackets or parentheses? Good. And the range, bottom to top, would be 0, 2, 3. Brackets or parentheses? Brackets. If they are open dots, you'll know. It would be an open dot like that. Okay, that would be a parentheses. You'll see it. You'll see an open dot. Good so far? All right, B, if I draw vertical lines through B at any point, do those vertical lines cross my graph at more than one point? Yes, so this is not a function. So if you think about what we talked about yesterday with your points, right? If I went to the graph at B and I said, what's the point here and what's the point here? You'd tell me it's 1 and almost 4, like 3.9. And then you'd tell me it's 1 and negative 3.9. So what's happening there is your x is repeating with a different y, which is consistent with what we said yesterday, right? It would fail my vertical line test. It wouldn't be a function, okay? The other thing is that this is an ellipse. An ellipse has an x squared and a y squared in it. Equals a number, right? Now my y is raised to an even power, which it can't have. So all of those rules overlap, okay? If your y is squared, it means it's probably turned on its side. It's going to fail your vertical line test. If it's an absolute value with a y inside, it's going to be an absolute value, or a v turned on its side. It's going to fail your vertical line test. All right, finding the zeros of the function. So the zeros are the same thing as the roots, the x-intercepts, the solutions. All of those mean the same thing. It is where it's crossing your x-axis. It's where your f of x equals 0. It's where your y equals 0. So those are all the same things. I think on the, I can't even remember. On the graphing calculator, it'll say roots. On your, I think on your graphing calculator handheld, it says zeros. Those all mean the same thing, okay? They are your x-intercepts, not your y-intercepts, your x-intercepts, where it crosses the x-axis. So for the, well, I'll get to that in a second. You would just set your equation equal to 0 and then factor if you need to, solve. The next kind of behavior you're going to talk about is increasing and decreasing. So increasing and decreasing behavior is moving from left to right. If your graph is rising as you move from left to right, then it's increasing. If it's falling as you move from left to right, it's decreasing. If it's flat or horizontal, it's constant. And your answer for these, just like domain and range, will also be given in interval notation. Max and min. So it's called relative max and min because it can be more than one. So a graph that goes up and down and up and down and up, again, has more than one max, and it can have more than one min. And the relative min is a dip in a graph. These are given in coordinate form. X, comma, Y, okay? An absolute max is there's only one absolute max, and absolute min, there's only one. So like a parabola has an absolute max or an absolute min. Those are different. There's only one of those. These can have multiple ones. All right, we're going to use the graphing calculator, and then we're going to answer the questions based on it. So we're going to go to our graph. We're going to plot this. Oh, I think this should be a minus. Hang on. Okay, you're missing your sign in there, but let's make it a minus. So then when we go to our graphing calculator, we're going to type in negative 2x squared minus 9x, and we're going to graph it. And it looks like this. So mine gets cut off at the top, okay? My max is not in the view. There's a couple different ways to get that into view. One is if you zoom, you can zoom out. You have to enter twice. It's going to zoom you out. You're going to get the max, okay? That's a teeny tiny. Oh. Okay, so there you've got your zoomed out graph. The other way is to adjust your window. So if you go into window, and you just adjust it because it was just a little bit off, like then the max and the min were fine on the X, but the Y max and min was what the problem was. So if I can make my min like negative 10 but make my max like 12. Now my graph looks like that, okay? So you can also just pinch and zoom on your graphing calculator app, okay? But you want to be comfortable adjusting your windows, okay? If it gets cut off, you're going to have to adjust. Sometimes when you zoom out so far, it's hard to see those things. If you click your trace button, it will let you move along your graph. If you hit your second calc button, there's a thing that says max, and it will take you exactly to the maximum point, okay? Okay, on the graphing utility, it will also do that, and you can hit the max. So on your graphing calculators, because you are going to have to graph something on a test using a graphing utility, and you're going to have to find max and min, okay? So we'll practice it a little bit more tomorrow, like we'll finish this stuff tomorrow, but I want you to get comfortable with it. If you haven't brought your graphing calculator with you, please bring it tomorrow so that we can work on it. Sometimes it's so exact that it gives you like a 4 decimal place thing. I'm going to tell you to round anyway, so don't freak out about it. It's going to be different a little bit from the graphing calculator app. But from here, just realize that if you graphed it, you could get that negative 2.25 and 10.125 would be your, and that's a max, a relative max. If it dipped down and came back up again, which we'll investigate some more graphs that way, then you'd get a max and you'd get a min, okay?